Hi, this is Barry Wise, President of Eigenvector Research, and I'm going to show you how to use the Hierarchical Model Builder in PLS, Toolbox, and Solo. The Hierarchical Model Builder allows you to build mixed hierarchical models. Well, why would you want to do that? The problem is that many classification and regression problems are just too complex to be handled with a single model. For instance, if you have a large classification problem with very many classes, you probably wouldn't be able to build a single partial least squares discriminant analysis model that sorted them all out. So instead, what you might want to do is break the problem down into smaller pieces. And then you could have rules that are based on the model outputs or even just single variables that are used to determine what to do at each step. As an example, we're going to do classification on the ARCH dataset. The ARCH dataset is an archaeological dataset. It's a classic dataset of Native American artifacts that are measured by X-ray fluorescence. There are 10 variables in this problem. The 63 known samples are from 4 different sources, quarries. These are actually obsidian samples that are from 4 known sources, and that's going to be our training set. The test set is going to have 12 unknowns where we don't know what location they came from, and we're going to try to assign them to the different quarries. This is what the raw data looks like for ARCH. So here we see each sample is plotted as a line, and we have the elements that are measured, their concentration in these samples across the bottom. So we have iron, titanium, barium, calcium, potassium, manganese, rubidium, strontium, yttrium, and zirconium. And the colors are by the classes, and that is what quarry they came out of. And for instance, here, the cyan ones came out of a quarry that we call AN. The dark blue samples came out of a quarry we call SH. The green ones are out of a quarry we call BL, and the red ones are out of a quarry that we call K. And then we have some unknown samples. We call that class 0. And those are the ones that we don't know where they came from that we're ultimately going to try to assign. If you do principal components analysis on the ARCH dataset, you get a very nice looking scores plot like this for the scores on principal component 2 versus principal component 1. And each of the classes of samples are circled in this diagram here. And we could see, for instance, that the AN quarry is very separate from the other 3 quarries. So what we could do is start with a PCA model that identifies, is it from the AN quarry? Then all we have to do is build models that separate the other 3 classes from each other. Well, if we do PCA on just those other 3 classes, on the K, BL, and the SH, we see that once the ANs are out of the picture, we do get a very nice separation between the BLs, the green ones, and the other 2. The SHs and the K. So we're going to build a PLSDA model to split the BLs from the other 2 classes. And then finally, we'll build one more PLSDA model that splits the K class, the blue ones, from the SHs. Excuse me, the K classes are the red ones and the SHs are the blue ones. And when we're done, we're going to have something that looks like this. This is our hierarchical model. And it's going to start by applying a PCA model. We're going to look at the Q residuals in that model to decide whether it actually is AN or not. If the Q residuals are small, we'll have an output that says yes, it is AN. And if they're high, we know it's not. And we're going to go on to another model that tells us if it's B or BL or K or SH. And then we're going to split that apart again and split it into finally K and SH. And when it's done, when we apply it, it should give us an output that looks like this. So here's our hierarchical model results output that shows what the classes in our 12 unknowns is. Before we can use the hierarchical model builder, we need to make the submodels that are going to go in it. So here I am in the PLS Workspace browser, and this would look the same whether you were in PLS Toolbox or whether you were using Solo. And I put a couple of variables in my workspace here already. The first one, Arch, is our whole Arch data set, and that's 75 samples, which includes our calibration samples from 4 different quarries, and then 12 test samples that are on the end of that file. Also, though, I broke off just the test samples, that last 12, as a separate data set right here that I'll call test. But for the moment, what I want to do is I want to start by making a principal components model on the Arch data. And so I've just drug Arch onto the PCA, and now we've brought up the PCA interface right here. And I'm just going to click model because I'm going to use the default settings of auto scaling here, and we can make ourselves a model on this data. And I'm going to go ahead and choose 4 components in this. But what I really like to do is look at a scores plot of it. And so I'm going to bring the scores plot up. And here that is. And I'm particularly interested in this one in the middle right here. And that is the scores on PC2 versus scores on PC1. So bring that up. And we can see here that the ANA class, I'll put the classes on by clicking on the legend here. The AN class is pretty well separated all by itself here. And that's the one that we want to start by working with. And so what I'm going to do is I'm going to go back over here to my plot controls window. I'll bring that to the front. And I'm going to say Edit, Select Class. And when I do that, I'm going to get a menu up here, which gives me the available classes. And I just want to work with AN because I want to make a model of just that class. So I'll select AN and say OK. And now only my AN samples here are highlighted. And then I'm going to exclude the rest of the data. So I'm going to say Edit, Include Only Selection. So I'm going to include only the part that I just selected. And then I'm going to make a model on just that. So now I've got data here that is only the AN data. So I'll go back to my analysis window and I'll tell it to model that. And I'm going to build a model on that using just 2 factors. Right there, I'm going to choose 2. And this is a decision that I would probably spend a little longer time making if I hadn't already done this a few times before. But I'm going to choose 2 there, and I'll say model. And now we can look at what our model looks like compared to the rest of the data. So here in my 3-figure window, this is just the AN class. That's not so interesting until we put on it the other data. So I'm going to say View the excluded data. And especially here in this top plot, we could see in the Q residual versus T squareds that we have a real separation. Here's my ANA stuff, my AN class down here in the corner, and here's all the rest of the data. Actually here, let's look at that a little bit bigger. This is my scores plot again. I'll say View the excluded data on that. And I can see that a lot of the data moves away from it in the scores plot. But in particular, if I plot that T squared versus Q residual, I could see that here's all my AN data down here in the corner, and here's all the rest of it. So that PCA model makes a nice separation between the AN data and the rest of the data. So I'm happy with that model. I'm just going to save it. I'm going to say File, Save Model. And I'm going to call that model something a little more obvious rather than the date and timestamp name that it will get. And I'm going to call that the AN underscore PCA underscore mod. So that's the AN PCA mod. And so now we have that one. And now what I'd like to do is make a model of in PLSDA of our BL versus my other two classes. So I'm going to start by re-including all the data. So I'm going to say edit, include all. And I'll confirm that. I do want to include all the data again. So now we have all of the data in our model. But what I want to do is I want to switch my analysis mode here from PCA to PLSDA. So I'm going to do that. I'm going to pick PLS discriminant analysis. And I want to set this up. I have to choose what classes I want to model. So here I just clicked the bent arrow button, and that brings up the class groups window. So I want to make a model where that BL class, which was the green ones, is a group by itself. And then I want to put the K and the SH classes together. So I'm going to model those as a group. And I'm going to say OK. And now I'm going to click the model button so I can make that model. And I'm going to take the default model here with a 2 latent variable model. And I could tell from the class error here that it gets it to, even in cross-validation, a class error of 0. So that model appears to work pretty well. And normally I would spend some time and investigate this model. But in this instance, I'm just going to go with 2, having spent some time looking at it before. And so I'm going to say File, Save Model. And this model, I'm going to call the BL versus KSH mod. And I'll put that right there. Maybe we'll put an underscore in it there. And say save. So now I have that model. And now I want to change the model that I've built here. So I'm going to bring my class groups back up again. And I'm going to remove them and start over. And this time what I really want is I want a model that separates K and SH. So I'm going to model K as a group, and I'm going to model SH as a group. So there my 2 groups are set up. I say OK. I'll generate that model right there. This model actually has a cross-validation class error that hits 0 with just 1 factor. So I'm going to choose the simplest model possible there and say model. And again, I would normally spend some time looking at this model, but now I want to get on with the example, and I'm just going to pick one. And I have looked at this before. And I'm going to save that model. So I'm going to say Save Model. And this model I am going to call the SH versus K model. And I'll say Save. So now I'm done using the analysis interface for the moment. And I'm ready to start using the hierarchical model builder. And notice that here in the PLS Workspace browser, I have my 3 models ready to go. I have my AN model that's just a PCA model of AN, and then I have the model BL versus K and SH, which splits BL from K and SH, and I have my final model that splits SH from K. So here in the PLS Workspace browser, we need to locate the hierarchical model builder, and that's under Tools here. So I'll open up Tools, and I'm going to double-click Hierarchical Modeling, and that will bring up my interface for that right there. And I'm going to start this by, it always starts with a rule, and it asks whether you want to make that rule be variable-based or model-based. And I'm going to say I want that to be a model-based rule. And it'll ask me where I want to find my model file. So I'm going to say I'm going to take that from the File menu. And I see here it is, AN PCA mod. So remember, this is the model that describes the AN class via PCA. So I'm going to say load that. And now that one is in there. And we're going to feed into another model here. So I'm going to put a rule in for that one. Right there. And it's going to go on to this model here if the Q from the last model is greater than 12. And that's something that I know from having looked at that PCA model. I know, having looked at the residuals on that PCA model, that if I use 12, that's going to be a high enough Q value that everything from AN should go inside the model and everything else should be well outside of it. And I'm going to load in also then the next model that we do, and that's going to be the B versus KL and SH mod, and I'm going to put that one in there. So now we've got things set up here. I've got my first model, Q greater than 12, it goes this way. And otherwise, if Q is less than 12, well, that means that it belongs to the AN class. So I'm going to output a string for that. So I'm going to drag the string icon here down to this. And so my test condition is the otherwise condition. That is, Q is not greater than 12. It's less than that. So that's otherwise. And I'm going to return a string as an output. And the output I'm going to say is class is AN. And I'll hit return. And now we're ready for that. And now notice when I put this other model in, since it's a PLSDA model with class outputs that we already know, it then splits these off. It decides, is it a BL, is it a KSH, or is it otherwise? So now here with BL, I'm going to have that finish as a string output if it's BL. And so I'm going to output class is BL right there for that. And otherwise, I'm going to do that branch here. I'm going to throw an error for that. And I'm going to say error. And my message is here out of BLK SH mod, and that is the error that we're going to get if we're outside the Q and T squared limits of that model. And now here though for K and SH, I want to put a new rule in here, and that is I'm going to go down here and we're going to make that a model-based decision rule again. So it's model-based, and I'm going to put in my last model, and that is my SH versus K mod right there. And that then will split us off into K and SH and otherwise. And if it's K, I just want to output that it is K, and so I'm going to say class is K. And here for SH, I want the output of that to be, if it is SH, I'm going to say class is SH. And then finally in the otherwise, I'm going to make that one an error. And that's going to be out of the KSH mod. So now I actually have my model builder all built with my branches here. It goes into PCA mod for the AN class. It checks the Q residual. If the Q is low, it's going to say that it is actually AN. If the Q is high, it moves it on to the next model, and that is a PLSDA model that splits BL from K and SH. If it's actually BL, it'll output that it is. If it is the KSH class, it will go on to the next model, and if it has too high of a residual, it'll go otherwise. And then finally here I've got my last model that splits K from SH, and it'll output information from those classes. So output class is K, or output class is SH, or an error that it's outside of that model too. So now to apply this model, all I have to do is actually drag my data set onto it. So I've got my test set right here, and I'm going to drag that onto the model, and it's going to actually apply that. And so here are my hierarchical model test results, and you see it says that the first of my 12 samples is an SH, and then I've got 3 Ks, and then 3 BLs, and 4 SHs, and then finally the last sample, it says that it's outside the BLK-SH mod. So that is a sample that is actually quite a ways away from the rest of my data. So there you have it. There's how to use the hierarchical model builder. We hope you enjoy using it and that you find it useful.